Hi guys, so we're continuing our conversation about gases, and today we're going to talk about pressure. What exactly is pressure? So pressure is caused by gases colliding with the inside of a container. So when we think about that helium tank, or we think about that propane tank attached to the grill, or an oxygen tank that a patient might be using to, in the little tube to get oxygen into their lungs better than breathing on their own. The pressure that those tanks are under is caused by the gases colliding or hitting the inside walls of that container. So the more molecules there are, the more helium there is in that balloon filling tank, the more collisions there are going to be. The fewer molecules there are, the fewer collisions there are going to be. So something we can really picture is a latex balloon, right? If we take a balloon and we blow it up and we put just a little bit of air into it, the balloon is not very big because there's not that much carbon dioxide in there pressing on the inside walls of that container. But if we put more carbon dioxide gas into that balloon, we keep blowing it up and keep blowing it up and keep blowing it up, we can actually blow it up to the point where it pops, right? It explodes because we've put so many carbon dioxide molecules in there that they're having so many collisions on the wall, so much pressure on that latex balloon that it can't handle it and it explodes. At the same temperature and pressure, doubling the number of gas particles doubles the pressure. So if we keep temperature the same, then if we double the number of gas particles, we're going to double the amount of pressure because you're doubling the number of collisions. If we halve the number of gas particles in a container, then we're going to halve the pressure because we have half the molecules making half the amount of collisions. And if we remove the particles from the container, then it will decrease. Just like if we take that same balloon we were blowing up and instead of blowing it up till it exploded, we let go of it, right, and it flies all around the room, then the balloon will eventually be empty, fall to the ground, because there's no pressure inside that balloon at all anymore. So Dalton's law of partial pressure is really easy. It's basically that you're adding up all the individual pressures that you find inside a container. So let's say we have a container that is filled with carbon dioxide, oxygen, nitrogen, maybe some helium. All of those individual pressures that those molecules are causing will, added up together, make the total pressure inside the container. And this makes sense because each of those are having a certain number of collisions on the side of the container, and when you add up all those individual collisions, that's your total collision. So Dalton's law of partial pressure is just the total pressure equals the pressure of one gas plus the pressure of another gas plus the pressure of another gas, and so on. If you only have two gases, only two pressures are added. If you have 20 different gases, then they're all added up. We can also figure out the prevalence, or how much of a gas there is in a container. So let's say we know what the total pressure of the container is, and we know what the pressures of each individual gas are. We can figure out how much of the gas is in there. So if we have a tank of oxygen and nitrogen, we can figure out what percent of that is nitrogen, what percent of that is oxygen. So that's two ways to look at Dalton's law of partial pressure. Let's get another visual on this. So here we have a container of a gas, and we see that the pressure of that gas is 2 atmospheres. Here we have a different gas, and the pressure of that one gas is 1 atmosphere. And here we have a third gas, and the pressure of that gas by itself is 3 atmospheres. If we take these 3 containers and mix them together into one container, then the total pressure will be 6 atmospheres of pressure. 2 plus 1 plus 3 equals 6. So we just add it up. Let's try a problem. So what is the total pressure in a balloon that's filled with air if the pressure of the oxygen is 170 millimeters mercury and the pressure of nitrogen is 620 millimeters of mercury? So we just add those 2 individual pressures together, and the total pressure inside that balloon is 790 millimeters of mercury. Let's look at a second problem. A balloon contains a mixture of oxygen and nitrogen. If the total pressure is 8.9 atmospheres, then what's the partial pressure of each individual gas? We know that the gas mixture is made of 78% of nitrogen and 22% of oxygen. So if 78% of the mixture is nitrogen, then it makes up 78% of the pressure. So this is a percentage problem, right? So we're going to take the total pressure, 8.9 atmospheres is the total pressure, and this is the percent of nitrogen. So remember, we change a percent to a decimal by dividing it by 100. So we've just taken that percent and made it into a decimal, and we multiply. And so we get that nitrogen makes up 6.9 atmospheres of our total pressure. Well, oxygen is even easier to figure out because we just take the total pressure, subtract out the nitrogen, and that means that oxygen is 2 atmospheres because these 2 together have to equal the whole. So this is the pressure of oxygen, this is the pressure of nitrogen, and this was the total pressure. And that is how we figure out partial pressure and Dalton's law.